present the topic on multi-stage transistor amplifiers. Myself Srishti Chaudhary, working as lecturer in Electronics and Communication Department, GPCG, Patiala. Now we have all studied in your previous subjects of second sem BE and BEE the single stage transistor amplifiers. So why we needed the multi-stage transistor amplifiers? The need for multi-stage amplifiers is that the amplification obtained from a single stage transistor amplifier was inadequate to drive the load circuits or the output devices, for example the loudspeaker. So thus to provide the adequate amplification, we needed the multi-stage amplifiers to a required level of strength. That is, the weak signals has to be boosted to a particular required level. For that we have to amplify the signal using a succession of stages, that is one after the another. Thus to amplify signal to required level, number of amplify stages are used in succession. It is arranged such that the output of one stage is considered to be the input of next stage and so on until the last stage is achieved. So considering this basic parameter or basic requirement for a multi-stage amplifier, the definition of multi-stage amplifier is given as such: a transistor in which a number of amplifier stages are used in succession or cascaded are known as multi-stage amplifier or cascaded amplifier. Here a block diagram of multi-stage amplifier is given. Here we are having different stages as stage 1, stage 2, stage 3 and so on until the stage n. Each stage has an individual gain, that is for stage 1 we have gain 1, stage 2 the gain is 2 and so on until stage n we are having the gain n. At the output or at the last stage we are having a load circuit, can be denoted by RL, and at the input input signal can be given and it can be represented or denoted by V in or Vs as the signal voltage. Now these stages are coupled from one stage to another and to the preceding stages by a interconnection or by a interface. That interconnection or interface is known as coupling. Now why we need coupling? Multi-stage amplifier output of one stage is connected to input of next stage through coupling device. Now this coupling device is required because we cannot connect the output of one stage to the input of next stage directly. Also the battery provided to the one stage single stage amplifier cannot be connected directly to the other stages of the amplifier in a multi-stage amplifier, as it will create the stabilization problems or operating point will be differed. Now coupling devices performs the following two main functions. First, it transfers only AC output of one stage to the input of the next stage, and second, it blocks DC components. Now type of couplings: as we couple one stage to the another stage, that is single stage amplifier, first stage coupled to second stage and so on, that how many, it depends how many stages you are employing. The thing or the parameter through which they are coupled to each other, that name us the type of coupling, that is RC coupling, and the amplifiers which employ these type of couplings are known as RC coupled amplifier. Similarly, if the coupling is transformer coupling, that is the interconnection between the two stages if is of transformer, the amplifier is known as transformer coupled amplifier. And last is the direct coupling. In this there is no reactive components are used, we are coupling directly one stage to the another stage, and amplifier employing this type of coupling is known as direct coupled amplifier. Now some basic definitions regarding this multi-stage amplifier we will discuss today. Starting from the gain of multi-stage amplifier, we all know that gain is the ratio of output to the input. Considering any parameter, any circuit, it is gain is considered output to the input. But if we have to consider the multi-stage amplifier, it is the ratio of output to the input of an amplifier or multi-stage amplifier. In case of multi-stage amplifier, first consider that the input is considered of the initial first stage of the multi-stage amplifier and the output is at the last stage of the amplifier. It is represented by G or A, and we can calculate the power gain, voltage gain or current gain similarly. Now again, to calculate the gain, consider the block diagram. We are having different stages, stage 1, stage 2, stage 3 to stage n, and if we assume that at the input we are having the signal V in, now this V in is the input to the stage 1. So the output after the stage 1 will be V in into G1, and this output is the input of the preceding stage, that is the stage 2. That is at stage 2 we are having the input V in into G1, and now the output of stage 2 will be input into G2, that is V in into G1 into G2. It is the output of the second stage. Similarly for stage 3, and at last at stage n we are having the input V in into G1, G2, G3 and so on if you are having the preceding stages in between, and this input is then multiplied by the stage n, that is Gn, and at the end last we are having the output, that is V in into G1, G2, G3 and so on into Gn. So the input of this multistage amplifier is V in, and output for this multistage amplifier is V in into G1 into G2 into G3 into Gn. This is represented that let V in be the input of first stage, and we are having the individual stages as gain G1, G2, G3 and so on. Now overall gain of multistage amplifier is equal to product of gains, that we will calculate now. But however in practice the overall gain is always less than the product because of the loading effect of next stages. The loading effect occurs due to the preceding stages if you are having the component as resistances in shunt. Now we have calculated this output of first stage, second, third and nth stage. Now the gain is the ratio of output upon the input. Just substituting the values of V out by V in, we have achieved V out, that is equal to G in into G1, G2, G3 into V in. Substituting this value into V out, we are having this equation. After a simple mathematical cancellation, G overall gain, that is equal to G1, G2, G3 into Gn. That is the overall gain of multistage amplifier is simply the product of individual stages of multistage amplifier. These are the individual stages. G1 is the gain of stage 1, G2 of gain 2, G3 of stage 3. So the individual product of gains give you the overall gain of the multistage amplifier. But in practice, the overall gain is less than this product of individual gains due to the loading effect. Now second definition is decibel. Decibel unit is provided to the gain, but in if we have to consider in theoretically, the no unit has to be assigned to gain of an amplifier, since it is the ratio of output to the input and the parameters for output and inputs are same, that is you are using the voltage, so there should be no unit assigned to the gain. But telephone industry proposed a logarithmic unit named Bell or decibel after Alexander Graham Bell. Now similarly, considering this logarithmic term, that if you have to find the gain in logarithmic term or in log, the basic formula is same, that is output upon input. For example, consider the power gain. Power gain means output power upon input power, that is P out by P in. And if we have to consider it in the logarithmic term, that it will, the formula will be log to the base 10 P out by P in Bell. But for practical purposes, Bell was a very quite large unit, so we doesn't use Bell. Therefore 1/10 of this unit is considered, that is decibel. That is considered more convenient unit for gain. So considering 1/10 of the unit, your power gain will be 10 log 10 P out by P in decibels. Similarly, voltage gain and current gain can be measured. It is 20 log 10 V out by V in decibel, and current gain is 20 log 10 I out by I in decibel. Here we have introduced 20. We all know that power is inversely or directly proportional for voltage and current by I square or V square. In log, the square terms get multiplied in before, that is it will be 2 into 10 log 10 V out by V in. So it will be appeared as 20 log 10 V out by V in decibel. Similarly for current, it will be 2 into 10 log 10 I out by I in decibel, that will be 20 log 10 I out by I in decibel. Now why we consider the unit decibel? It is because overall can be determined by just adding them. We have just calculated the gain of multistage amplifiers, that is the product of individual gains of the stages, that is G1 into G2 into G3. the multiplication can be complex. For example, that the gain of first amplifier is 500, the gain of second amplifier may be 300, and so on. In case of gain of absolute value, it will get complex with the multiplications. But in case if we use the decibel, we have to just add the different gains. For example, 500 can be converted into decibel unit, again 300 can be converted into decibel unit, and that decibel units has to be just being added. That is, individual stages gain has to be just added in case of decibel. That is, for example, we consider that gain of first stage is 10 dB, gain of second stage is 12 dB, gain of third stage is 12 dB. And if we have to calculate the overall gain, it will be just by simply adding these three decibel values, that is 10 plus 12 plus 12, that is 34 dB, the overall gain. Also, very large gains on linear scale can be denoted by small figures. That also we have discussed that absolute values are very large, that is 500 or 600, or it can be 324. But if we convert it into decibel, the large values are denoted by small figures, that as 10 dB, 10 dB, 12 dB, or 14 dB. Now, second definition is the frequency response. It is the curve drawn between the voltage gain and the signal frequency. It is shown here. At one axis we are having the voltage gain, at the y-axis, at the x-axis we are having the frequency response. The voltage gain of an amplifier is not constant, that is, it varies with signal frequency. As the frequency changes, your voltage gain changes. It can also be understood by the simple formula. We all know that reactance Xc is equal to 1 by 2 pi Fc, that are inversely proportional. As the frequency increases, your reactance decreases, or vice versa. That is, if your reactance increases, your frequency resistors are necessary in case of your RC coupled amplifier. Now the application for your RC coupled amplifier, it is used as voltage amplifier as in initial stages, that is this RC coupled amplifier is not used at the last stage of the multi-stage amplifier, as the impedance matching is very poor in case of your RC coupled amplifier, that is the maximum output power is not achieved with respect to your input power. So this RC coupled amplifier cannot be employed at the last stage of the multi-stage amplifier. These amplifiers are employed in the initial stages of multi-stage amplifiers to provide the boost or signal strength to the weak signals. Now considering the second coupled amplifier, that is your transformer coupled amplifier. Now again considering the first consider two stage amplifiers. This is your first single stage and this is your second single stage transistor as an amplifier. What we have changed or what we have modified this from your RC coupled amplifier is this, the coupling is changed. As the name indicates, you are using a transformer to couple your first single stage amplifier to your second single stage amplifier, the transistor amplifier. So you have replaced your RC, that is your collector resistance. The output is taken across this transformer secondary. The simple way to draw this circuit again is to draw two stages, first single stage cascaded to this your second single stage. You are having two stage amplifier now. Now the again purpose is to couple these two stages now through a transformer, that is you are providing a transformer coupling between the first stage and the second stage, and this is provided here by replacing your resistance RC by this transformer. Now here we are having transformer with primary and secondary. Through transformer action